There are several reasons that command line skills are crucial for bioinformatics or pretty much any other type of big data analyses. For example, command line tools can handle data files that are simply too big to open in many programs. In addition, if you need to utilize high performance computing resources, you'll probably interact with those by way of command line. This video gives an initial introduction, addressing things like accessing a terminal and understanding the basic components of command line commands. If you work on a Mac or Linux system, you can easily access a terminal on your own computer. On my Mac, I find it from the Launchpad. The icon is generally a square black screen similar to the one pictured here. If you use Windows, you probably won't have a terminal available on your computer, but there are still options. If you have access to a high-performance compute system, you could use the terminal there. If you need help logging onto an HPC system, check out the video on that topic. Alternatively, if you're an academic researcher, consider checking out Cyvers, which is an NSF-funded project that provides high-performance compute resources for research. Finally, you could also search around online for resources that provide options to practice within a terminal. Once you have your terminal window open, you should see a prompt. On mine, there's the name of my computer, then the name of my working directory, which is just a folder on my computer I'm currently in, then my account name on this computer, Sovic.1. Finally, there's a $sign, followed by a flashing cursor. Yours might look a little different, but what's important is that this prompt indicates the computer is ready for you to give it a command. There are a few basic components to doing command line computing: commands, arguments, and output. We'll focus on these components for the remainder of this video. Now, let's give our first command. At the prompt, we'll type pwd, which stands for print working directory. Pressing enter sends the command to the computer, and the computer gives you some output. In this case, the output is the specific path through the hierarchy of folders on your computer to the one that is currently serving as your working directory. For now, don't get too caught up in working directories and exactly what this command is doing. The important thing to focus on are those basic components of command line computing. Here, we've seen two of them: commands and output. We've given the computer a command and it returns some output. At a very simple level, everything you do at command line will involve these two things. Let's try one more command. At the new prompt, type ls, which is the list command, and again, press enter. By default, this command lists the contents of your working or current directory. It's similar to double-clicking on a folder to open it up and see what's in there. In my case, I have 4 items in my working directory: 2 files, calculations.xlsx and out.csv, and 2 folders, data and software. Again, don't get caught up in details of what this command is doing. The important things are the components of command line computing that are represented here: commands and output. Now, let's take a look at a third component: arguments. Think of these as details that modify a command's behavior in some way. Let's give the same ls command, but this time we'll add the -l argument. Make sure to put a space between the command and the argument. Here, -l stands for long format. When I run the command with the argument, I see those same 4 items: the calculations Excel file, the out.csv file, and the 2 folders, data and software. But this time, there's some additional information printed for each of these. The -l argument changed the behavior of the ls command, causing it to provide additional information in the output. Let's take a look at the information in one of these columns, which represents the size of each item in bytes. For example, the out.csv file is about 1.4 million bytes. Now, let's try the ls command again, but this time we'll include 2 arguments, -l and -h. The output looks pretty similar to before, but the way the sizes are presented has changed. That -h argument means human readable and makes it a little easier to read the file sizes, especially when files get really big. Again though, what's most important is that we've given the computer a command, along with some associated arguments that modify the command's behavior, and it returns some output. One last thing about output. So far, all the output has been printed to the screen. This is typical as a default, but it can be redirected to other places. Let's rerun that ls-l-h command again, but this time redirect the output to a file. You could type the command in again, but instead, Try just hitting the up arrow on the keyboard one time. You should see the last command you entered. If you need to, you can hit it again to see the command before that, and so on. While you work a command line, the computer keeps a history of all the commands you enter. The up arrow scrolls backwards through those commands and is a handy feature you'll use a lot. Back on topic though, before pressing enter, we'll use the right arrow to redirect the output to a new file named contents.txt. This time, when you press enter, all you see is another prompt. A couple things actually happened though. First, a new empty file was created with the name contents.txt. Then, the command was executed, in this case, ls or list, and the output that would have otherwise been printed to the screen was redirected and written to this new file. If we run ls again, there are now 5 files in our directory, including the new contents.txt file. If we were to view what's inside that file, we would see the same output that was printed to the screen when we ran that command without redirecting the output. The big picture here is that there are a few basic components to working a command line: commands, arguments, and output. And the output will typically be printed to the screen, but can be redirected elsewhere, with the right arrow representing one widely used method for redirection. Once you feel comfortable with these basic principles of command line computing, you're ready to start focusing on some of the commands themselves. The videos on navigating in the terminal and organizing your files will be logical next steps.